Hello everyone. In the last chapter, we had an introduction to vectors. We saw different examples of lists, how the vectors are just stripped off versions of lists, and how they belong to different worlds. Then we saw a few operations on vectors such as addition, subtraction, and scalar multiplication. Let's move on to learn about matrices in this chapter. Imagine a superstore that sells different kinds of fruit boxes, each with a different combination of fruits in it. We can club all this information into a single table or a content chart. This content chart is going to play a major role in the operations I'm going to show you soon, so I will keep it here in the corner for reference. Imagine that I buy two boxes of type A, one box of type B, and three boxes of type C. Can you find out how many fruits of each kind will I have? I'm putting this basic equation here, and then we can replace the boxes with its actual contents to get the equation. Now we can use the scalar multiplication we saw earlier, and now we will do the vector addition to get our final result. Do you remember how we started with a list and stripped down the first column to get a vector? Similarly, the first column and first row of the content chart can be stripped down to get what is called a matrix in mathematics. And the operation of finding the number of fruits from the boxes that we performed is called a matrix vector multiplication in mathematics. The above operation looks like this in matrix and vector notation. Pay attention to the world indicator or the subscript I have used with each entity here. The 213 is a combination of boxes, so it is actually a vector in box world, and that's why it has a subscript or world indicator B. The matrix translates this box vector into a vector in fruit world. That's why the subscript for it reads as an arrow going from B to F. We have already seen a fruit world before, which had fruit vectors, and now we have introduced a new world, a box world here. The content chart or the matrix we just saw acts as a bridge between these two different worlds. We can use the matrix as a reference book to translate values from box world to fruit world. As you can see, the fruit vector belongs to fruit world and box vector belongs to box world, but the matrix doesn't belong to any particular world. For fun, I like to think matrix as a vector churning machine which takes in one vector and spits out another. In this case, it takes in all different kinds of boxes, removes the packaging, and gives out these different fruits. Look at how the different dimensions work together seamlessly in this case. The box vector is a three-dimensional vector and we have exactly three columns in the matrix. The fruit vector is a four-dimensional vector and we have exactly four rows in the matrix. It is not a magic though, because we knew about the dimensions of the fruit and the box world while building the content chart or the matrix. We can also represent this idea with a simple diagram. It will help us in the long run when we create more worlds with different dimensions that somehow connect with these existing worlds. We have already seen how the fruit world and the box world are connected together. Let's up our game now and introduce another world, a package world. The boxes were made from combination of fruits and these big packages are made from combinations of the boxes. As you can see, there are two types of packages in the package world, package type X and package type Y. We had a content chart or a matrix to describe the translation from boxes to fruits. Similarly, assuming a particular combination of boxes in these packages, we can build a content chart from package world to box world. I'm going to list our content chart from boxes to fruits here for reference, and also here is the content chart from our package world to the box world. Now suppose I order 4 packages of type X and 3 packages of type Y. Can we calculate total how many fruits of each kind I have ordered? We can use the package to box translator to get the number of each kind of box I have purchased. I am intentionally not representing it using our list form. See if you can read the vector form without any problem. If you cannot, then pause and ponder and try to find out the meaning of each entity here. You can go back to earlier slides and understand the vector notation and the world indicators, and then proceed only when you are confident about the above operation. Seems like I have purchased 10 boxes of type A, 18 of type B, and 25 of type C. Now I can use the box to fruit translator to get the number of each kind of fruit I have purchased. See how we have used two matrices here to translate my order from package world to box world and then from box world to the fruit world. Let's look at the vector churning machine diagram for the above process. We started with my package orders or the package vector 4, 3 and then used the matrix from package world to box world to find out the number of boxes of type A, B, C, which is 10, 18 and 25. Then we use the matrix from box world to fruit world to find out the total number of apples, bananas, oranges and kiwis. It is wonderful to think how these vectors, which although look very different and even have different dimensions, represent the exact same stuff in the real world. In the next chapter, we will see how to combine two matrices together to create a shortcut between two disconnected worlds, and then we will see a very interesting one-dimensional world which can be interpreted in different ways. See you then.